Okay, 29 of the notes. Let's take a peek. It says, this is from an AP classroom question. It says, hey, using the values in the table above, estimate f prime of 4, and they're trying to trick you on something, guys. If we're estimating f prime of 4, f prime just means slope. How do I get slope back in 7th grade? How do we get slope? Or from a table? Change a y over change an x. So don't overthink this. What are my y values in this table? X, f of x, or f prime of x? It's just f of x. So if these are really my y's and this is really my x's, how am I going to estimate, look what they said, estimate f prime of 4.
4 minus -1.
Yes. He's saying, okay, 4 would be somewhere between 3 and 5, right in the middle. And he says, oh, it's the change in y over the change in x of those 2 points. Do they want you to take the average of these? Probably. You know what I mean? Like, they're trying to trick us, you guys. But this is good old school slope, change in y over change in x. So Mr. Ritz said, oh, we got to do 4 minus -1 over. You got it, bud. Could we end right there?
Yes.
Yeah. Could also be 5 over 2. You guys, you know where you can't end? I mean, you cannot only show this one. Bob, I know you just want to go right here, buddy. Good. So AP needs to see, this is called a difference, because we're subtracting quotient. They've got to see that to give you the point. Sound good? Okay. Let m be this function. Find m prime of 3. If we're just adding these two things together, when you go to take their derivative, you can just add their derivatives together. So m prime of 3 would just be f prime of 3 plus h prime of 3. They gave us f prime of 3 right here. F prime of 3 is how much? 8. Okay. Then we've got to go find h prime of 3. You guys, here's h of x. And I purposely did this because we got to go remember how to use our calculators for this. So everybody, does anyone remember math? Oh yeah, math 8. We got to go math 8. Go type in this function. So we're finding the derivative. And then you're going to say when x equals 3. Negative 2.061. He says, we done. Agreed. If this was multiple choice, theirs would be 5.939. But it doesn't matter. What is n involving now? N says, hey, let n be this function. N is f times h. Find n prime. Do you agree my function n has multiplication going on? So what rule do we have to do? Product rule, which goes fig plus gif. Exactly. So we're going to take n prime of 5 is going to be, you guys, how would we product rule this? It's the derivative of the first times the second plus the derivative of the second times the first. F prime times g plus g prime times f. Yeah? So we're going to say f prime of what x value? 5 times my second function, h of 5, plus, what would we come next? Y'all are on fire today. H prime of 5 times f of 5. So that's the derivative of the first times the second plus the derivative of the second times the first. All right, y'all, f prime of 5, did they give us that info? F prime of 5, they gave it to us as 3? Yep. All righty, so we got a 3. Times h of 5, you guys, again, this is calculator active. And does yours not say that? My bad, I printed this for next year. Yours says calculator active? Okay, good. Mine needs to say calculator active as well.
Well, it just says it up at the top.
Oh, good call. Up here. For next year, I've put it for each question. Okay, calculator active. You guys, how are we going to go use our calculator to find h of 5 if here's h? Here's h. How am I going to find h of 5? You just plug in 5, you guys. Everybody go plug in 5 just as good practice. It's not the derivative. I just need 5 squared times e to the cosine of 3 times 5. 11.695. 0.695 plus. How are we going to do h prime of 5 now? Now we go back to math 8, or if you could just do the up arrow and just change where you want that derivative, because it's the same function, e to the cosine of 3x, and we want that derivative, just change that 3 to a 8 this time? Wait, what do we want? 5. We want to negative 18.138, and then we need to multiply that by f of 5. F of 5 is 4. Done. Okay, now P is H divided by F. Find P prime. Find P prime. We got to do all about me, people. Low D high minus high D low all over low low. So we got low D high. So P prime of 7 is going to be the lower function, F of 7. Low D high times the derivative of the higher function, H prime of 7. Low D high minus high D low. All over low, low. We got to use that table. What'd they give us for F of 7? 6. H prime of 7. I'm just going to hit the up arrow, and I'm going to go back to my derivative, and I'm going to change my x from 5 to just be a 7. And I got negative 63.024. And just be careful. I feel like when I have negatives, I put parentheses around it just so it doesn't look like 6 minus 63.024. Okay, that's low D high minus, how am I going to get H of 7? I'm going to go back into where I just plugged in. I think it was a 5 before, and I'm going to change all my 5s to a 7 personally. You could type in the whole thing again, though. 28.335? Thanks, Rai. Thanks. And then times F prime is 7. F prime is 7 from my table? Close, isn't it?
It's negative 2.
Negative 2. F prime of 7 is negative 2. All over, what was F of 7? Oh yeah, now I'm ready for you, Dean. F of 7, that's 6 squared, and we can be done, y'all. So in 210, we just have these 1, 2, 3, 4 more derivatives, but I'm here to say AP really only asks tangent and secant derivatives. They really don't ask cotangent and cosecant. So I'm going to let you know what they are, but we're not going to really focus on those this year. Sound good? Okay, so we do need to know the derivative of tangent, so we're going to go derive it. We're going to go prove it. We're going to go figure it out, even though we don't know what it is. How can I rewrite tangent in terms of sine and cosine? Sine over cosine. So do you guys agree if I just say the derivative of tangent is the same as the derivative of sine over cosine? Have I changed my problem? I haven't changed it because tangent and sine over cosine are the same thing. Now, we didn't know what the derivative of tangent was, but I do know what these two derivatives are. Let's actually remind ourselves. What's y? What's the derivative of y? I'm sorry. If y is sine, what's the derivative of sine? Cosine. If y is cosine, what's the derivative of sine? Perfect. So, to find this derivative, it's got division, right? This has division in it. So we got to do the quotient rule. All about me. Let's do it. What's the low function? Love it. D high, the derivative of the higher function. The derivative of sine? Good. Low D high minus high D low. Close. Derivative of that lower? Negative sign. Yep. All over low, low. Okay. Let's simplify that top, y'all. What's that top going to simplify to be?
Cos squared of x.
Cosine squared of x plus?
Let's go sine squared of x.
Sine squared of x. Very good. All over cosine squared. Hey, you guys, last year I had you tattoo something on yourself. What is sine squared plus cosine squared? Isn't that 1?
Yeah.
So we know we've got 1 over cosine squared because this is a Pythagorean identity. Sine squared plus cosine squared is 1. What is 1 over cosine? Secant. So 1 over cosine squared? Secant squared, Bob. You just found out the derivative of tangent. is secant squared. So we're going to go throw that right here. The derivative of tangent is secant squared.
Couldn't you also do
So we've got these derivative rules. Finally, the derivative of natural log. 1 over x. Good job, you guys. I am going to have us put these other two in, but I'm here to let you know that don't ask these two, okay? It's not that, I mean, I've just literally never seen these two on the AP test and the hundreds of tests I've looked at. So the derivative of cosecant is negative cosecant cotangent. But we don't have to worry about that one. And the derivative of cotangent is negative cosecant squared. I'm here to say we need everything else. I wouldn't worry about those two. Okay, write the equation of a tangent line. Okay. Anytime they ask us this, which they will in a free response question, you will get 1 point for that, or maybe even 2. They're looking for a point slope form, y'all. They're looking for that. In order to do point slope form, y'all, what do we need? A blank and a blank. Point and a slope. True. We do need a y and an x. That's my point, which I would typically say x and y. And then we need a slope too, right? That's fair. Y and an x. I agree. And a slope. Bob, which one do you want to find first? The point or the slope? There's no right answer. Whatever fits your fancy. Let's do the slope. All right, if there's my function, Bob, the slope is going to be the derivative, and we just learned it. What's the derivative of tangent?
1 over cosine squared?
Careful and simplify it.
Secant.
Secant squared. You got it. Do we need to have that memorized eventually? Yeah, we will, though. We'll get it memorized. You guys, where do they want that derivative? At what x value? Yes, sir. And then it's like, oh, man, we got to remember the unit circle. Sure do.
Well, it's easy because it's one of the ones where it's the same for each.
They match. I agree. Root 2 over 2 and root 2 over 2. But secant is the x value, which is root 2 over 2, but it's reciprocal, right? Secant isn't cosine, it's the flip of it. So if cosine was root 2 over 2, what's the reciprocal of that? 2 over root 2 squared. That's going to be my derivative.
So it'd be 4 over 2.
It'd be 4 over 2, because 2 squared is 4, root 2 squared is 2, which is 2. So my slope is 2. Boom. We know my x was pi over 4 because they gave it to us. But to Bob's point, we need y minus y. We need a y coordinate. Yeah, Dean says, well, if x is pi over 4, just plug that into the function right there to get my y coordinate. Tangent at pi over 4. To Cooper's point, he likes pi over 4 because they're both root 2 over 2, root 2 over 2. Tangent is y over x. Any number over itself is 1. So I might just put this off to the side that the f of pi over 4 was the tangent at pi over 4, which was just 1. And that's how I got that y coordinate. Boom. We got to go quotient rule to find this derivative. Find the derivative of g. Here we go. What's my low? Secant. Thanks for the participation. I appreciate it, Bob. D high. Secant squared x. Derivative of 4. Very good. Low d high minus high. What's high? Yeah, if that's not in parentheses, it's wrong. It's kind of brutal of me to say, but just being honest. Got to be in parentheses. Low d high minus high d low. Derivative of the lower. Gosh. Secant x. Don't forget the x's, you guys. I know I often just say secant tangent, but we got to have x's in there too. Secant of the angle, tangent of the angle. All over. Low, low. And if you wrote secant squared like this is great. These are both correct. You want to know that what it's not equal to? That is not right.
Is that secant of x squared?
Exactly. That's only squaring that x. Good. Either of those. Nice. This goes back to yesterday. When they give you this form, they're asking for the derivative without saying f prime, without saying derivative. This is asking for the derivative. They told you what the function is. What's the derivative of secant? Secant tangent. Yep, we're going to be flipping over to that chart for a while, and that's okay. So f prime of x is just secant x tangent of x. Where do you think they want the derivative in this case?
Pi over 3.
Yeah, that x value right there. They want it at pi over 3. So then we'd say secant at pi over 3 times the tangent at pi over 3. Yeah, sometimes we don't even have to answer it. Phew, simplify it rather. Okay. Oh, ooh. What rule do we have to use on this one?
Product rule.
Yeah, we got to go product rule because I've got one function times another function. We got an f times a g. Product rule says fig plus gif. Fig plus gif. F prime? Negative sign. Good job remembering that cosine. I'm sorry, remembering that negative. F prime times g. What's my g going to be? Tangent. Fig plus gif plus g prime. Derivative of my second function. Good. We're getting those memorized. Good job, you guys. F prime times g plus g prime times f. Good old cosine, right? And dang it, does that look like any of the answers? So they're making us simplify on this one. Shuckle buckles. How can I rewrite? So we did this in Unit 11 last year, and this was like Pythagorean identities, simplifying. How can I rewrite tangent? Yeah, so I'm going to just bring down this sign, and then I'm going to rewrite tangent as sine over cosine. How can I rewrite secant squared? 1 over cosine squared. Okay, so this secant squared is 1 over cosine squared. I'm just going to bring this one down. Yes, because isn't this really just cosine over cosine squared right there?
Yeah.
Yeah, so I agree, bud. One of them's going to cancel. Boom. So let's go multiply these together. So I've got a negative sine squared over cosine plus 1 over cosine.
Negative sine plus 1, is that, that's the rearrangement, it's like negative.
You're exactly right. He's like, hold up. Sine squared plus cosine squared. I know sine squared plus cosine squared is 1. Well, first of all, actually, before I even say that, Ritzy, we got common denominators, guys. So can we add these up? Yeah, let's go put those together. And Ritzy's saying, he's saying negative sine squared plus 1 over cosine. That looks familiar to my man Ritzman, and he is right.
That equals cosine squared.
Negative sine squared plus 1. In order to get negative sine squared, wouldn't I bring this over there?
Yeah.
And so 1 minus sine squared, or negative sine squared plus 1, would equal cosine squared. Good recall. So this is going to be negative cosine squared. Final answer.
Why would it be negative cosine squared? Wouldn't it be positive?
Oh, golly, isn't it going to just be positive? Thank you, Cooper. Because oh my goodness, Coo, what would I do without you? I appreciate you, dude. Guys, so this is now really putting all of Unit 2 stuff together. This is good. Whew, lots of things. And I don't believe it's calculator active. Okay, let's put some stuff together. It says, according to this model, what is the average rate of change of the amount of dirt removed from 6 to 12 hours? And they're saying, I didn't even read the thing. An evacuation state, the amount of dirt has been removed in cubic meters is F. Okay, dirt is F. G is the differentiable function that T is measured in hours. Values of G of T are given in the table above. Interesting. Okay. Find the average rate of change of the amount of dirt removed according to F. Okay, check this out. From 6 to 12 of F. From 6 to 12, what do I need to refer to? G. That's why I know I used these, but I thought I did it wrong. But it's saying according to the model F, looking at F, what is the average rate of change of the amount of dirt removed from 6 to 12? That means I got to look at G. All right, from 6 to 12. Average rate of change goes back to 7th grade, folks. What minus what over what minus what? Perfect. Are you done? Yup. You can be done. Without a calculator, even with a calculator, we're going to fat fingers sometimes, we're going to mistype it. So we're just done. Use the data in the table, to approximate f prime of 9, we're approximating. They know it's an estimate when x is 9. Let's just start with that. Let's just end right there.
Oh, what is it? 428 minus 376.
Yeah. He's saying f prime of 9. Again, 9 falls between 6 and 12. So I'd have to go back to g of t. 9 is right here. And again, if they want the approximation of that slope, we're going to just do y minus y over x minus x right around 9. AP is going to ask you this, I promise. And we're going here to get those points. He said 428 minus 376 over what, buddy? That's it. Okay, this is a good circle back now. Is my function continuous? Let's remind ourselves what the heck continuous means. Is this graph continuous? Yeah. Is this graph continuous? No. Is this graph continuous? No. Okay. Is this graph continuous? No, right? So continuity, for something to be continuous, the limit has to equal the value of the function. So if we go back to the one thing that was continuous, the limit here has to equal the value of the function, meaning that dot has to be plugged in. So it says between 0 and 12 is my function continuous. And all that means, you guys, is we got to go up and look at our function. And between 0 and 12, where's our only potential break? At 6. So we got to make sure the limit from the left of 6 equals the limit from the right of 6. Let's start with that. Let's go start with that. The limit as x approaches 6, or I guess it's t in this case, right? As t approaches 6 from the left is going to be which function? The upper one or the bottom one? 6 from the left. Upper. T is less than 6 would be the upper. So I'm going to just go ahead and put in 48 times 6 plus 6 squared minus 6 cubed over 12. And I'm actually going to just let you know, because that is calculator active, but I'm just going to save you time. That's 306, y'all. Okay, then we got to compare that to the limit from the right of t as t approaches 6 from the positive side.
It's 306.
Hey, he says, as I approach 6 from the positive side, I got to look at g. Here's g. 6 from the positive side, 8 is bigger than 6. So as I come in from the positive side, what's that value going to be? 306. So we're going to say equals 306. Actually, I'm going to specify that I did that from g of t, and that equals 306. So does the limit from the left and the right equal each other? What about f of 6?
It exists.
F of 6 is going to be g of 6, right? And it's still 306. I love it. So would we say continuous or discontinuous? Continuous, and here's why, you guys. A lot of people miss this point on their Unit 1 test. Because the limit as t approach 6 of my function equaled the value of the function there, 6. Find f prime of 2. Find the instantaneous rate of change. Instantaneous rate of change is that derivative using my power rule, quotient rule, product rule, using my rules. They want the actual slope at 2. At 2. Do you guys agree 2 is here? Yep. All right, we got to go find this derivative. So we're going to say f prime of t. Let's first find the derivative with respect to t, then we'll go put in a 2. I'm going to bring this down so I can see it a little better. Old lady eyeballs, here we go. Get rid of this guy, and here we are. Okay, here's my function. We need the derivative of this one. We got this, people. Derivative of 48t. 48. The derivative of t squared. 2t. The derivative of t cubed over 12, which is the same as negative 1/12 times t cubed. These are the same thing. And that might help you when you've got to bring down your exponent. What would 3 times negative 1/12 get me? 3 times negative 1/12. Yeah, we just multiply straight across. Awesome, Beck. Negative 3/12. You guys okay with that? So we could say negative 3/12 or 1/4. T to the second. Love it. You guys, they wanted f prime of 2. So now I'm just going to go replace every t with the 2. F prime of 2 is 48 plus 2 times 2. I'm going to go say 3/12 is 1/4. times 2 squared. I just threw in a 2 for all of my t's. Just because we got the time, let's do it. What is 48 plus 4 minus, what's this going to get me?
1.
Yeah, 2 squared is 4. 1/4 of 4
51.
is 1. I agree, I got 51.